Today is lecture 1 of hydraulic machinery. We will discuss about the basic definition of hydraulics, and then we will study the pressure, force, and area relationship. Then we will see about the Pascal law, then what is hydraulic press, and working of hydraulic brake, and at the end we will discuss the conservation of energy. So, first of all, what is hydraulics? Basically, hydraulics is a field, engineering field, in which we transmit the force with the help of liquid. Basically, it's based on a Pascal's law, and this is an example of transmission of force with the help of fluid, in which you can see that the piston is moving outward and then piston is moving backward. It's happening because oil is provided into the cylinder, which pushes the piston to outside. This is another example of hydraulic jet. It uses the same principle and uses the Pascal law. Now, what is pressure? Pressure is a force acting on a unit area and is usually expressed in pounds per square inch or Newton meter per square inch. Pounds per square inch is also called as PSI, and Newton per square meter is also called as Pascal. This is the basic equation of pressure, which pressure is equal to force divided by the area. This is different units used for pressure: Pascal, bar, kilopascal, megapascal, pound per square inch, inches of mercury. In Pakistan, we mostly use PSI and kilogram per square inch. Then we will see, now we will see the pressure force area relationship. We use pressure force and area triangle to see the relationship between them. This is the pressure, force, and area triangle, in which P represents the pressure, F represents the force, and A represents the area. With the help of this triangle, we can find three different relationships: one for pressure, one for force, and one for area. So, if we want to find the force, if we are given the if we want to find the pressure and we have given the force and area, we can use this equation. Pressure is equal to force divided by the area. Now, if we want to find the area and we have given the force and the pressure, and we can use this equation: area is equal to force or pressure. And if we want to find the force and we have given the pressure and the area, we can use this equation: force is equal to pressure multiplied by the area. Now about the units. In the previous equation, the unit of force is pound or Newton. It depends on which system you are using. Then area can be in inches square or square meters. And then pressure is the pound per square inch, Newton meter per square inch, or Pascal. So basically, the whole hydraulics branch of hydraulics study is dependent upon the Pascal law. So Pascal law states that when the pressure is applied on a confined liquid, the pressure is transmitted in all directions and acts with equal force on equal area at right angle to them. So this is the basic principle behind all the hydraulic systems. Simply, when force applied at any point over the liquid can be transmitted to another point using the incompressible liquid. This means that if we have a confined liquid and we apply the force on one side of it, we can transmit applied force to the another side or another corner of the container in which the liquid is confined. So we can see the Pascal example. Here there is a bottle, glass bottle, which is filled with the water, and we put a small force on the stopper of the bottle. Let's say the pressure equal to the force divided by the stopper is created in the fluid. And let's suppose that this force is, when the force we have applied is 10 watt, and the area of the cork or stopper is 1 square inch. Then the force applied to the pressure applied mm, to the liquid is 10 psi. When we apply the pressure over the cork, it will develop a pressure inside the bottle. This pressure acts against the equal area of the bottle, and the resultant force is multiplied by the bottom area of the bottle. So, if the area of the bottle is 20 per square meter, so square, each 1 meter inch square will receive a 10 psi pressure, which we have applied on the cork. So, if the area of the bottom of the bottle is 20 square inch, then the total force uh, we have generated by applying a 10 pound force, we get 200 pounds of the force. Due to this increase of the bottle, of the pressure bottle can be break. You can see that. Remember a simple rule of thumb in hydraulics: a small force on a small area creates a proportionally large force over a large area. If we applied a small force over a small area, as you can see that we have applied a 10 pound force over a small area of 1 inch square, it produces a 200-pound force for 20 square inch area. So let's have a small numerical here. What would be the force? What would the pressure develop if the force of 50 pounds acts on an area of 1 square inch? So what will be your answer? It's 50 multiplied by 10 is 500 psi. So now we will discuss the basic principle of the hydraulic press. Hydraulic press uses the same principle which is described by the Pascal's law, which states that which can be short resulted that we can multiply the force on small area to the force on the large area. If we apply a small force on small force on a small area, we can multiply it by a large area. Hydraulic press is also called as Brahma press after the name of its inventor Brahma in 1795, and it was invented in England. This is the basic diagram of a hydraulic press, in which you can see that there is a small piston and there is a large area piston. Here we have applied a 10-pound force with an area of 1 inch square, and larger piston has an area of 10 inch per square. So if force of 10 pound is applied on the piston of 1 inch square area, the resultant system pressure on the smaller piston is 10 psi because pressure is equal to force over area. And when we divide the force of 10 pound by area of 1 inch square, we will get the pressure of 10 psi. Then this pressure is transmitted to the fluid and it will move the or balance the piston with the larger area. So the force on the larger piston is pressure into area, and if we have the pressure of 10 psi and the area is 10 inch square, then we have a force of 100 pounds on the larger piston. The force balances downward force of the 100 pound due to weight of the cylinder. As the weight of the cylinder is 100 pound, it will be balanced out. Now we will discuss about the hydraulic brake. Hydraulic brake is working on the same principle. A small force is applied on the brake pedal, whose area is small. The pedal transmits the resultant pressure through the hydraulic oil, and force gets multiplied on the brake piston, which has larger area. So here you can see that there is the brake pedal. Here is a small piston, which when we apply the pressure, it will transmit by the liquid and by liquid to the brake cylinder, which is relatively larger area as compared to the brake piston. Now, now we will discuss about the law of conservation of energy, which states that the energy can never be created or not destroyed. But uh, multiplication of engineering of force in hydraulic gives us the impression that the energy is being created because of the force multiplication. But this is not the case, and an energy is made in terms of amount of work done. So work done is defined as work divided by the torque is equal to force multiplied by the distance. The previous example, force is on a small piston is sufficient to move a large piston. You can see that there is a small piston and we have applied a small force to move a larger piston. However, it must be noted that small piston moves 10 inches to move a larger piston. The important thing is that is to remember that the smaller piston is moved 10 inches to produce a force of 1100 psi. If smaller piston moves by 10 inches inside the container, the volume fluid displaced is calculated at as the volume is equal to piston area multiplied by distance. So piston area is 1 square inch and the distance moved is 10 inches. So the total volume which is displaced by the piston is 10 inches cube or 10 cubic inch. Hence the amount of work accomplished or force over a distance is same for both the pistons. So work done by the small piston and the large piston is same in for the both cases, and we can prove it mathematically. This proves that the energy cannot be created nor destroyed. But there is only force multiplication. We have not created any energy, but we have applied the multiply the force. The volume displaced by the fluid pushes the larger piston by the distance which larger piston moves is calculated at. We have we have applied the force on smaller piston which has an area of 1 square inch and it moves 10 inches. So as a result of this, the distance moved by the larger piston is equal to the volume divided by the piston area, which is 1 inch. So the smaller piston moves 10 inch and the larger piston moves 1 inch. So we have compensated our movement, our displacement. So we can say that the movement of the piston is inversely proportional to the area. If the piston area is small, then we have larger movement. And if we have a larger piston, or piston with a larger area, we have a smaller movement. For example, in the last case, last example we discussed that the piston has the area of 10 1 square inch and it moves 10 inches. But the larger piston has an area of 10 square inch, but it moves only 1 inch. So thank you very much for the class.